This is pretty self-explanatory. You just have to put yourself in a car and kind of think it through. A student is sitting in a moving car, and through the car window, the student sees a traffic light at an intersection pass by and out of sight as the car travels down the road. Which statement accurately describes the student's motion? Well, your best answer in this one is going to be B. I'm just going to point it out. Because the student is moving relative to the traffic light, but not to the car's window. When you get in the car and you're driving down through there, the car is going. Is the window moving? No, the window's not going anywhere. So your best answer in this one here would be B, okay? Number 27.
Boy.
All right, now I'm going to have to flip it back and forth, and I'm going to do some explaining with this one, okay? Neap tides and spring tides. This is the way I taught my kids in class for a review out here. Spring tides they go in a straight line, okay? Neap tides they go at 90 degrees, okay? Now, they only happen whenever you have a new moon and a full moon.
Now, but show us how the moon and you have the earth and the moon. So,
Okay.
what do you mean straight line, Miss House?
So when you have the earth and the moon
Lined up, and then the
Lined up.
sun.
and the sun. Now, if you have neap tide, they're going to be in a 90 degree. They're going to look like that, okay? Now, I also need to tell you about the moons, okay? When you look at moons out here, moon process, you're going to have a new moon, because he's going to be brand new, okay? He's going to be brand new out here. I'm going to look at my notes for a second, because I write stuff down to kind of help you out. Simple, that's why I look back at these papers. We have a new moon, but then you have a first, okay? And then you have a full moon. And then you have a third moon.
So the first and third are like quarter moon, so they're like
Yeah.
half.
Yeah,
Okay.
you only have a half here going on. Now, I'm gonna let you know that spring tides and neap tides means that you've gotta have some movement. Okay?
Either full or new.
You gotta be a full or a new when you do this, okay? All right. Let's go back to this question. And it says, study the data on spring tides and neap tides for the beach in the month of June. A tide height of 0 represents the average of the low tide. So they took the average, and we're going to say that 0 is going to be the average, which is a low tide, okay? You can look at the heights here. 8 and 7, this 8 and 7 are the high. So we know that that's got to be our full moons and our new moons. That's how we know they're going to be a full and a new. And we know that they happen on June 5th and June 21st. That's how we know that. So we go through our chart, and as you went through and looked at this, you're going to look for 5 and 21. 5 and 21.
Should say full and
Full or new. Okay? You're going to run into this. Notice this one says full and new. I'm going to scroll down and show you the other two real quick. And notice what they say. This one says first and third. So we know that B is going to be a wrong answer. Okay? Third and first. So we know D is a wrong answer. Okay? Now, let's go back up to A and C. So we know B and D. We're out on those. Remember how I said over here? New, first, full, third. So when we come up here and we look at these questions in here, what will come, and how you do it, okay? We're going to look for a full, third, full, first. What comes after full, third?
So they got to stay in that order and then repeat. So after third should be new, then first, then full. So no matter where we start,
Wherever you
they
go,
stay in that
yes.
same order.
See? So here we have new, first, full, third. New, third.
No, the
Full,
third always
first.
comes after full.
So we know that here we have new. He's number 1. New 1. New 1. A is our better answer.
Okay.
Like this one. So A is our better answer in that one, because we don't go from new to third. We
Okay.
go new to first.
Gotcha.
Let's go with the next question. Okay, I'm going to draw on this one to kind of help you out. Look at what the kids go through in class.
Put it up just a little bit, Miss House, so that we can see. Oh, okay, right. Oh, yeah. Well, it probably won't stay there.
All right. So, with this being said, on all of this, we're going to look at this picture. Now, when you look at this picture, remember anything that bounces back is called a reflection. So this is the light going down. Okay? And the question says, a ray of light is traveling through the air and it strikes the surface of the glass and it is refracted. The diagram shows 4 different paths. Which one is refracted? So which path would be the refracted one is what we're looking for. Remember, if it bounces back, it's called a reflection. So we know that these here are going to be our reflections.
Now, hey, Miss House, you might want to show them that there is a vertical line that should have been drawn. Nope, yeah. See how the glass?
This is the glass.
No, that's not the
Oh,
glass.
The glass here.
No, the glass. The draw a vertical line where the glass up and down. Go up. Yes.
That way. Okay.
That is the piece of glass.
I'm sorry.
You see what I'm saying? Because
I know what you're saying.
when I look at it,
In the
it
picture-
almost looks like the glass is like horizontally.
I'm sorry. For
No,
the
no, no.
picture-
I'm just
For the
making
picture
sure.
for you all to see it at home, you all can't see when I'm rolling
Yeah.
up and down.
There you
My fault. My fault on that one. All right. So when the light hits this glass, that's what's
Yeah.
happening. Okay?
Okay.
That's called the reflection because it hits this glass and it's reflecting back. Okay. Now, when it goes straight through the glass, okay, this is called
transmission.
or transmission. Okay? Because it is passing. Remember the other day I said pass, transmit, like on the radio, it's going to pass through. All right. Now, when it goes and it makes a bend, this is called a refraction. This is a bend. It's a refraction. So, when we look at the letters that I wrote all over, W, X, Y, Z, we see that Z is the refraction, okay? So if we look for which one is Z, D would be our answer, okay, in that one. 29. Now I'll roll this back down for you. You want to see it, you want to see it better. Okay. A student designs a system to model how information can be sent over various distances. The student investigates 2 methods to send signals. One method is by speaking into a pickup connected to a string to represent an analog phone. The second method is creating a series of light flashes that where a certain number of flashes correspond to a letter to represent wireless computer network. The table shows the results. So we're looking at, here is the cup and string. It goes 5 and 10, and the accuracy is 90 and 5. Okay? Notice that the longer the string went with this, that the accuracy was not as great. Okay? Then we did a series of light flashes. And they went 5 meters and 100 meters. And notice with these light flashes that they were 100% accurate on this. Okay? So which characteristic of wireless computer network does the student's investigation represent the most on this one? And if you want to look at it, our best answer in this one is B. And we looked at it, if you look at all of this, look at the distances. A wireless computer network takes longer time to transmit a signal 5 meters than analog. No, not according to our information.
Well, it doesn't even say anything about time up there.
Correct. B, wireless computer networks are reliable in transporting signals over different distances, and this is where we're looking at, we're doing the different distances. We can do, we're 100%
And it says distances up
in
there.
5 and 10, 5 and 100,
Yeah.
okay? So wireless, which is our flashing, is reliable over different distances. We went 5 and 100, those are different distances, and we're still 100% at each one of these. Wireless computer networks depend on a receiver. This has nothing to do about a receiver. It didn't say anything about a receiver. The wireless computer networks create signals that become stronger farther distance as it travels. Okay? Well, this one is not showing that because remember, we have different distances and we're both at 100%.
It didn't say anything about any type of strength of that signal.
Correct. Let's go to number 30. Okay, I'm going to just throw this out here with this question. This is a bad question in Ms. House's opinion, okay?
And we didn't make it.
We don't make these questions, okay? A student designs an experiment to test the strength of an electromagnet, and the data table shows the different trials that the student completes during experiments. Which question is best answered by this experiment? Now, I'm going to tell you right now, the best answer for this one for you to be able to do your work at the house, C is the best answer that they are choosing, okay? They're picking C. When you do an experiment, you should only have one thing you want to change. That's called the independent variable. Remember that from earlier this week. Independent, I choose. It starts with the letter I choose to test. You can't change up something when you're testing something. So you can't change the wire thickness. And you can't change the thickness of it. If you're testing it, make it one thing. You need to test just the thickness and then get your results. Or you should change the loops and it just be the loops that you're changing. Or the voltage or the current, okay? There is a reason that you only have one independent. And with this question, it's not giving us a dependent variable, which is our measurement. We don't know how much they're picking up. We don't know how much current's going through it. Okay?
Well, what the strength of the magnet
Yes,
is.
what is the strength of the magnet? We don't know what is the strength. It doesn't tell us how many paper clips it picked up. It's not telling us that strength. So, C is your best answer here.
Even though A and B could possibly be answers as
Correct.
well.
D is that for sure.